So hope all of you have enjoyed the lectures in the last week and doing well. Today we'll continue ahead with more things about differentiation, more techniques and methods we'll learn in differentiation. Just wait a couple of minutes for more students to join in. Right, so this is going to be session number 7 for us, and we're going to continue ahead with applications of chain rule, differentiation by chain rule. We will discuss about some of the questions in the worksheet number 3 that I have sent. Even though I've actually sent you the solutions for most of the questions, but still might need to discuss some of the questions. Okay, now before I begin, Dharmik, it's a pen tablet that I use, like this kind of thing. This is the pen and the tablet. Okay, it's very difficult to write like that with a mouse. It's little difficult to write with a pen tablet also because, you know, as you can see, the tablet doesn't have a screen. It is just a writing board. So you have to look into the screen while you're writing on the tablet, but that is something that people do with practice. Okay. But writing with a mouse would be extremely difficult. This is the kind of tablet that most graphic designers and all use. Of course, they are much more skillful. They do very good art with it. I just merely write some things. Okay. Anyhow, so we're discussing about application of chain rule, and let's. Ajay, before I forget, I checked about your major test 1. Unfortunately, actually, there was some mix-up, and the wrong set of questions of calculus was given to you. So that's why a lot of the questions in that test were actually, you had not learned that method in calculus at that stage. So it doesn't matter. Like, don't take the marks that seriously. Okay, I will be giving you another DPT, a daily practice test kind of thing for calculus, which will be actually the original set of questions I had sent for your test. But for whatever technical reason, the wrong set of questions had got uploaded. So you can treat that like a self test of half an hour, because it has limited number of questions on calculus. And of course, now you have learned further, but you can just test yourself on that. I will send the answer key a little bit later, so you can maybe tomorrow or day after, when you have some half an hour free time at home, you can do it as a self test, and that will be basically the questions that you were supposed to have done in major test 1. But don't worry, now major test 2, you will be better prepared for it. Okay. Yeah, so coming back to composite functions and chain rule. So applications of chain rule. So today what we will see is that, of course, we can always apply the 3-step method that I taught you last time for composite functions. That is, the first step is the substitution step. The second step is the chain rule, and the third step is resubstitution. So whenever we have for any composite function, function of a function. Okay, let's just quickly revise the chain rule method that we discussed. Step 1, was we substitute and we introduce a dummy variable. So substitute gx as z, let's say, or any variable. So that becomes our, what we can treat as our dummy variable, which we'll have to later resubstitute. Okay. But then the moment we define gx as z, y becomes a direct function of z, becomes very simple. So then the next step becomes that when we want to find out rate of change of y with respect to x, now we cannot differentiate directly because we have now defined y in terms of z and z is in terms of x. So we define it as rate of change of y with respect to z multiplied with rate of change of z with respect to x. So this is what we call the chain rule step. This statement that we have written, in fact, it's a chain rule because we are establishing a chain of three variables. Y is related to z, z is related to x. Okay. And then of course we substitute this here, so we get d by dz of fz multiplied with d by dx of gx. Okay. Now, of course, we can write the derivative of a function in short form using the dash or prime notation. So this will become f prime z into g prime x, where prime means it's the rate of change. So dy by dx has come up to here. And finally, the third step, we want to remove z. So we have to resubstitute. We have to resubstitute z as gx. So dy by dx will become derivative of f applied on gx multiplied with g prime x, or derivative of g. Okay. So this becomes like a final formula we have. So as I told you last time, that at this stage it will be better that you first practice various questions that you're doing with the proper application of all these steps. And once you're comfortable with these steps, then you can come to a stage where we can start applying this formula directly. Okay. So there's any doubt in this? You can let me know.
No, sir.
Okay. So let's look at some examples. Now gradually our difficulty level of examples will increase, but let's start with something like this. So we have y is equal to, let's say, yeah.
So can you scroll up for a second?
Yeah.
Sir, we have to copy it, no?
Not necessarily, because this is a recap of what you've done last time.
Okay, sir.
So
fine.
you will not copy this, but as long as you are clear with the steps, if there's any doubt in any of the steps, please let me know.
Okay, sir.
Clear now all the steps?
Yes.
Okay, very good. So now let's see an example. So we have y is equal to square root of 1 plus x square, let's say. Okay. So this you can see it's an example of a composite function.
Can you go to the previous slide?
Yes, sure. Okay. So you want to find dy by dx. Okay. So those who are finished with that one, just note down the question and start working on it. Then I'll go back to that previous one. Just note down this question, this example, y is equal to square root of 1 plus x square, and start applying the methods of chain rule in this. Okay. So we will use chain rule for differentiation.
So you already gave this question.
This question we've done last time.
No. Yes, sir. We have done this one.
Okay, so let's do another question. Okay. Doesn't matter if you've done this, is fine. So we will do y square root of sine x.
Okay.
So we'll find dy by dx, and we'll also find the value of dy by dx, the derivative, at x equal to, let's say, pi by 6. Okay. That is 30 degrees. Let's do this. Okay. Yeah, so just rewrite the question as square root of sine x. Okay, and work this out. So now we will discuss this question by both the methods, the fundamental 3-step method, as well as we can also discuss about direct application of the formula.
Sir, is the answer that I sent correct?
Beta, little bit louder, please. I couldn't hear you.
Sir,
Harsh?
is the answer that I sent correct?
Is the answer what? Square root?
Sir, is the answer of this question correct that I have sent right now?
Acha, you were sent. Okay, okay. Just let me check. Just a moment. No, Harsh. You have to simplify a little bit more. Yes, Vedant, your answer is correct now. Okay. And Vedant, your answer to the earlier part was also correct before I changed the question. Yes, Amin, very good. That's correct. I might have got your name wrong. Your name is Amani, is it? Okay. Can we do sin x to the power half and then use no? So basically, this square root of sin x means it's sin x to the power half.
Yes, sir. That only we can do it sin x raised to the half, and then
Yes.
use the normal functions.
Exactly. You know, so that is how you have to use the composite function concept. That
Okay, sir.
on x we have operated sine first, and on that the power half. Right?
Sir,
Yes, Harsh.
sir, in this question, can't we differentiate first? Can't we differentiate them and then put the value?
हाँ वही करना है ना, पहले differentiate करके ही value put करना है. First you have to find, see this is y, then you have to find dy by dx, and then you have to find the value of dy by dx at pi by 6. So you have to substitute x as 30 degrees of pi by 6 in that. Understanding? No? That's the only way you can get the answer. First you have to differentiate. So I'll go by the step-by-step method first. Then we can see how we can use shortcut. So this is, if you think about it like this, this is a function of the type f of gx, where you can see that on x we have operated sine first, the sine function. So that is our g. So we've got sine x, that is our gx. And then on that we have operated square root function. Okay, so that is our f. So we've got square root of sine x. That is our f of gx. Okay. So we will substitute, first step, we will substitute sine x as z, because generally we substitute gx as z. So our y becomes square root of z. Okay. So this is a step that we are applying. This exactly. Okay. The next thing, chain rule. So we'll apply the chain rule here. Dy by dx will be dy by dz into dz by dx. So in this case, that will become differentiation of root z with respect to z multiplied by differentiation of sin x with respect to x. So that is 1 by 2 root z into cos x. Okay. And this basically is your this step, that it is f prime of z into g prime of x. Okay. And then finally the resubstitution step. So substitute z as gx, which is sin x. So our answer becomes, as you can see, cos x upon 2 root sin x, which is basically dy by dx is f prime of gx into g prime x. If we write it as a formula, you can see this is the step. Okay. So this is the answer to our first part. This is our dy by
We can
dx. Now our
further
second part.
simplify it with cortex, right? We can rationalize the denominator, which will make things
Sorry,
easier.
a little bit louder, please, beta.
Sir, we can rationalize the denominator, right? Then ऊपर हमें मिल जाएगा.
Can't hear you. Can you speak into your mic a little louder?
Sir, can you hear me now?
Sir is saying that can't we rationalize the denominator so that
You can
we
rationalize.
get-
That's correct. You can rationalize the denominator, or you can also, write cos x as root x into root cos x into root cos x. So you can express it in two different ways also. Okay. So you can do all that. So there are a couple of alternate ways in which we can write the answer. So one of them here would be that, as you said, we can rationalize the denominator and write this as cos x into root sin x divided by 2 sin x, or basically that will become root sin x
into cot x.
cot x divided by 2. Okay. Or we can also write dy by dx as square root of
Can it sin x upon tan.
cot x into cos x. This way also we can write. Right. So anyway, whatever. Now the second part, we want to find the value of dy by dx at x equal to pi by 6. So just substitute the value of x as pi by 6 in this. Okay. You just take this here and substitute this. So that becomes cos pi by 6 divided by 2 times square root of sin pi by 6. So that, as you know, is root 3 by 2 divided by 2 into square root of half. That will become root 3 divided by 2. Or you can write that as root 6 by 4, whatever. So this is the answer to this problem. Okay, so hope this question is clear to all of you. Okay, very good. Now, also, how could we use the shortcut formula? Let's see also. So, alternately, what we can do is that since it is given that y is square root of sin x, or y is f of gx. So we know that dy by dx in general will become derivative of f of gx, okay, into derivative of gx. So now we can understand here what is our function f. Our function f is square root function. So what is derivative? So for example, if I had f of z, what is, okay, so derivative of that is 1 by 2 root z. No? So this will become 1 by 2 times square root of gx. Okay. And what is our gx? Our gx is sine. Okay. And what is our gx? Gx is sine x. So g prime x is derivative of sine x, which is cos x. So this is this into cos x. So you can directly see that it's cos x upon 2 times root sine x. So when we are a little bit experienced with the steps, we can skip a few steps and do this directly. Instead of that substitution, resubstitution and all that, we can directly see that we have this function square root of sine x. So dy by dx will become differentiation of the outer function. So that is square root function. Okay. And inside we have sine x. So that into differentiation of the function inside, which is sine x, which is cos x. So you can see it becomes cos x upon 2 root sine x. Okay. So let's take another example. So this time we have, let's say, ln of sec x plus tan x. Okay. And we want to find dy by dx. So first of all, note this down. And next, what we'll see is in this next example, I will go directly with the shortcut method first. Okay. So it's not really a shortcut method. It's like we are directly substituting instead of substituting step by step. So we are doing some of the steps in our mind directly. That's the thing. So it requires a little bit of practice and experience in differentiation.
Sir, you're on mute, sir.
Yeah, very good. Sec x is the correct answer. All of you sent it. Okay. Many of you sent the answer. Sec x is the correct answer for this. So in this, if we treat this function like f of gx, then what is gx? Gx is sec x plus tan x. And what is f of gx? It is natural log of gx. Okay. So we know from this that what will be our g prime x? It will be differentiation of this. So differentiation of sec x, as you know, is sec x tan x by formula, and differentiation of tan x is sec square x. Okay. And f prime of gx will become 1 upon gx. That is 1 upon sec x plus tan x. Okay. Because we know that differentiation of log function is 1 upon x. So if I replace the x with gx, what I'll get? 1 by gx. So now from that we can understand that dy by dx will be f prime of gx into g prime x. So as you can see, f is the log function. So log's differentiation is 1 upon, but 1 upon what? The quantity we have applied log to. So that is sec x plus tan x. Okay. Into derivative of gx. Now gx is the bracket inside here. So its derivative, as you can see, is sec x tan x plus sec square x. And then there's a bit of observation here that if you take sec x common, then the numerator is the same as the denominator. So you can directly write this as sec x. So our differentiation's value becomes sec x. So the correct answer that all of you sent. Okay. Okay, so hope this question is also clear. Okay, now next we
Yes,
move
sir.
on to slightly next level of question, where we have to use more than one technique in differentiation in the same question. So for example, we have a question, y is equal to, let us say, cos x into e raised power sin x. Okay. You can see it's a product of two functions, and not only that, one of the functions that we have taken the product, e raised power sin x, is a composite function. So you can observe that y is the product of cos x and e raised power sin x. Okay. So you'll have to use the product rule of differentiation. Okay. And additionally, e raised power sin x is a composite function. It's a f of gx kind of function. So you'll also have to use chain rule. So to find
So,
differentiation, yes.
Sir, in this case, we'll have to differentiate e raised to sin x, and then whatever the differentiation comes, we'll also have to differentiate it with cos x.
Yes. So you will have to use that separate thing of e raised power sin x as differentiation in your application of product rule. Understood, na?
No, sir.
Okay, I'll explain. Okay. I'll explain step by step. Just note this down first. Okay. So we want to find dy by dx over here. So, first, so what we'll do here is, let's say we'll treat y as the product of two functions, or we can just treat it like two variables itself. Okay. So let's say it's u into v, where u is what it is cos x, and v is what it is e raised power sin x. So now to find differentiation, we first of all will use the product rule. So dy by dx will become differentiation of the first function multiplied with second function plus first function multiplied with differentiation of second function. So this step is clear.
Yes, sir.
So now you see here, when I want to substitute, the first thing is very easy. U is cos x. So differentiation of u with respect to x is very simple. It is sin x. Sorry, minus sin x. Okay. But v is what now? V is e raised power sin x. So what about differentiation of v with respect to x? So we have to use chain rule. This is like an f of gx right now. So this will be f prime of g into g prime x. Now tell me, what is the f in this outer function? क्या है?
function is
नहीं, outer वाला exponential है ना, और
Yes,
inside
sir.
वाला sin है, right?
sin x.
Yes, sir.
So gx is sin x, na, in this.
Yes, sir.
Okay. And f of gx is therefore
Is
e
e
raised
sin
power gx. Now what is the derivative of exponential?
Sir, e raised
E
to
raised
x is
power
e
x
raised
only.
to x.
Differentiation of e raised power x is e raised power x only. So derivative of this is what? E raised power sin x.
Sin
only.
x.
Yes.
But g prime x will become what? It will
Cos
become
x.
cos x.
Sir, it would become cos x.
Okay. So this term is cos x. So my dv by dx, this term is becoming cos x into e raised power sin x. So I'll have to use this over here now. So I have to substitute this term here. Is it clear now?
Yes, sir.
Yes,
And of
sir.
course, this term here. Okay. So this now becomes dy by dx is equal to du by dx. Okay. Just overwritten here. So let me do this. Okay. So du by dx, which is basically what it's minus sin x into v, which is e raised power sin x. This whole thing plus u, which is cos x, into dv by dx, which is
Cos x
cos
e
x
raised to sin
e raised power sin x. Okay. And then we can take e raised power sin x common, and we can write this as
Cos 4x minus 2.
Yes, we can write it as cos square x minus sin x, whole thing multiplied with e raised power sin x. Understood now? So how in the same question we had to use two different properties of differentiation. One was the product rule and the other was the chain rule for composite functions, right?
Yes, sir.
Any doubts, people? Okay, so just make a note of this.
So,
Yes.
so can you explain for dv by dx, like du by dx I got as cos x, so it will be minus sin x, but for dv by dx
हाँ,
what-
dv by dx में देखो ना मैंने क्या किया, I use the chain rule thing directly using the formula. But if it's not striking directly, then we can also use the step-by-step method. So step-by-step method will be like this: that our v is e raised power sin x. Okay, so here we can take sin x as z. So what does our v become? E raised power z. Okay, so this is
Yes,
our first step. Then our second step is I want to find dv by dx. But abhi kya hai? V is not directly related to x. V is related to z. So this will become dv by dz into, now z is related to x. So into dz by dx. So this is my chain rule step. Okay, this is my substitution step. This is my chain rule step. Okay. So now what is dv by dz? It is differentiation of e raised power z. क्योंकि मुझे पता है क्या होता है, by formula क्या होता है, e raised power z ही होता है.
yes sir.
और ये क्या है, dz by dx क्या है, sin x का differentiation है, which again by formula you know cos x. So second step is done. Now third step, resubstitution. So z has to be substituted as what? Sin x. So dv by dx is becoming what? It is becoming cos x into e raised power sin x, because we have resubstituted. Okay, steps are clear now?
Yes sir.
Okay, very good. So as I said, like if you are, you know, if you require to do the 3-step process instead of directly substituting, there's no problem. Okay, as long as the thing is we don't make a mistake while doing the differentiation is fine. And at some stage when you have done enough practice, you will see that automatically you will be able to skip these steps and do this directly. So you'll see that there's no difference between what I've done over here and what I've done here. It's just that some of the steps here we have skipped and done it directly. We have directly substituted this, whereas here we have done it step by step. So that being able to do it directly is just a function of practice, it's nothing else. So it will come to you, don't worry. My God, it's really raining very heavily at my part of town. Okay, so hope this question is clear to all of you people. Done with this now?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay, so we have more or less come to the last part of differentiation applications. So just need to practice some more questions of different difficulty levels. Then we can move on to the next part. So let's try some questions. So we want to find dy by dx for the following. Let's take y is equal to, let's take another exponential function. So this time we'll take x square plus 2x. Okay. Then let's take the example of Okay, so just try this out. I'll start giving you the answers in a couple of minutes. Just try it out yourself in the meantime. Yes, very good, Arushi. That's correct. And Harsh, very good, correct. Tejas, correct, very good. You have to just substitute Z again, but other than that, it's correct. Okay, so I'm giving the answer for the first part. I'll work out the steps also later. You should get this as, you can just write it as this. Okay. Okay, very good. Correct for the second one also, Arushi. Vedant, correct, very good. Okay, correct, Harsh. Okay, third one. Third one will be a little bit complicated. Yes, so it can be simplified a little bit more, but basically we can leave the answer this way.
Sure.
Okay, so let's discuss each of these. So by far the first one is the simplest, because the first one is like this. You can think of it as f of gx, where f is the exponential function and g is this quadratic function. So dy by dx, f prime of gx into g prime x. Now f is e raised power gx. So f prime of gx will become also e raised power gx. So this is e raised power x square plus 2x into g prime x, which is the differentiation of this, which is 2x plus 2. That's how we get dy by dx as so this is the direct way of doing it. Otherwise, you can use the substitution method. You can substitute x square plus 2x as z. So y becomes e raised power z, and then use the chain rule. Then so you become e raised power z into 2x plus 2. Okay, so that just becomes. So this is the step-by-step method. This is the direct method.
So,
Yes,
g prime x you wrote as 2x plus 2.
yes.
So,
That's differentiation of x square plus 2x, no?
अच्छा हाँ okay okay.
ये g का differentiation क्या होगा? X square is differentiation which is 2x plus 2x is differentiation which is 2, right? So that's why.
And so similarly for f prime.
Okay, so
Okay,
this is the
sir.
differentiation of this, which is 2x plus 2. Whereas f prime is exponential function only. So f prime of gx is what? Exponential of gx. So it's this one.
Yes, sir.
Okay, now the second one is simple, but again lengthy, because you can see that a lot of things we have to do in it. There is this product of two functions, sine square x into cos x. Okay. And then another function added. So when we're looking at this, we can see that dy by dx is differentiation of this first term, which is sine square x into cos x, plus separately differentiation of sin x. So this is the easiest part, but here it's a product of two functions. And in this product, one of them is a composite function because it's a sine square x. So this is a composite function. This is a simple function. So this will further become like differentiation of sine square x into cos x, okay, plus sine square x into differentiation of cos x, and plus this term separately, which is just cos x. So now this is the one where we have to use chain rule. So you can see that we are differentiating sine square x. So it is like we are differentiating some function square. That will become 2 times that function into the derivative of that function. So this will become 2 sin x into differentiation of sin x, which will become cos x. So that's how this term will come out to be 2 sin x cos x into cos x plus sine square x into sin x, sorry, minus sin x, okay, plus cos x. That's how we get this final expression. Now, once again, like you might want to just do this separately using the steps of chain rule method. So you can do that also. We just want to separately understand this step here, the differentiation of sin x, sine square x step. Okay. So let's take z equal to sine square x. So we can substitute sin x as some new variable. Let's say u or something. Okay. So z becomes u squared. So this is my substitution step. Now my second step, chain rule. So I want to find dz by dx. Okay. So that will be dz by du, because now z depends on u, into du by dx, and u depends on x. Okay. So dz by dx becomes differentiation of u square, that is 2u, into differentiation of u sin x, which is cos x, and then finally resubstitution. So dz by dx is 2 sin x cos x. Okay. And that is what this is, because z is sin square x. So we can do this step and substitute that over here. So this step, say this step has come from here.
Sir,
Yeah.
sir, can you explain me that second last step?
In which one, the chain rule? This?
No, sir. No, sir. Another one.
Then here.
Yeah.
That is what I've explained over here. When I want to differentiate sine square x, na, okay, you have to use this chain rule method. It is square of a function, na? So
Yes,
square
sir.
का differentiation क्या होता है? 2 times the function, but into g prime x, because gx is sin x. You understanding na? See this term z. So this term that we are differentiating sine square x, if you treat it like a new variable z, what is z? Z is u square, where u is sin x.
Yes, sir.
Understood? Na? So your z is u square. So your differentiation of z with respect to x will be differentiation of u square, which is 2u, into differentiation of u with respect to x, which is cos x. So that 2u is nothing but 2 sin x. So that's how this term 2 sin x is coming, into differentiation of sin x, which is cos x. Is it clear
Okay,
now?
sir. Okay, sir. Thank you.
Okay. Okay, so like it's like, you know, if I directly give you the question that differentiate sine square x, you know what to do. No? It's very simple. You have to just do these steps. Okay. But now that's sort of plugged in this question. There are more things to do because sine square x is multiplied with cos x, and then to that whole thing we are adding sin x. So you have to just break it down into smaller steps. So for this part, we have to use the product rule. So, and then for having used the product rule, we have to use chain rule for the differentiation of sine square x. So basically, this whole term's differentiation is split into these two terms. So here to here, we are using the product rule. And within the product rule, you can see that this function is composite. So its differentiation is, we are using the chain rule.
So,
Yes.
so in this step by step of the chain rule, you took only sine square x as z, or you took differentiation of sine square x into cos x? That complete.
No, I took z as sine square x. Okay, so that's why I'm replacing finally now. I'm replacing this dz by dx is only differentiation of sine square x, because my z is what? Sine square x.
Okay.
So that is why in this step, this differentiation of sine square x is replaced with 2 sin x cos x. That's this term.
Okay, then you mean to say then when we got 2 sin x cos x, then we also need to multiply it with cos x. So that becomes
Yes,
2
yes.
sin x cos square x.
So it's like, you know, here only I can say that in this function, when I've written this function this way, sine square x into cos x plus sin x. Okay. Now in this only, let me say that y is equal to some z into cos x plus sin x. Okay. Where what is z? Z is sin.
Sir, here z would be sin x then. Sin square.
Sorry, come again.
Z would be sin x.
No, z is sin square x बेटा. क्योंकि z को मैंने ये वाला टर्म लिया ना जो cos square x से मल्टीप्लाई किया, and further therefore z, this is becoming how much? Sin x is becoming a new variable u. So z is equal to u square. Got it now?
Yes.
So it's like, you know, using chain rule multiple times.
Sir,
Yeah.
sir, I have a doubt.
Yeah, tell me.
Sir, I'm not getting to understand the second last step of that chain rule.
This now, okay, I'm explaining this again. Okay. So see this function once again here. So y is equal to sin square x cos x plus sin x. This is our original function. Okay. Now इसमें ना मैं क्या करता हूँ, sin square x को I'll substitute as z.
Yes, sir.
Got it? So now when I differentiate, what I have to do, dy by dx will be differentiation of z into cos x, okay, plus differentiation of sin x.
Yes, sir.
Okay. Now this is the product of two things, so I'll use product rule. So next step, I use product rule. So this dy by dx will become differentiation of the first term dz by dx into cos x plus first term z into differentiation of the second term cos x. Right. So this has become my product rule, whereas this term is just cos x. Okay. So now see in this, what is dz by dx? So for that I have these steps. This whole thing over here. Okay. Z is sin square x. So how to differentiate z with respect to x? By using this product rule. This chain rule. So here, so for this differentiation, I'll use this step. So dz by dx is coming out to be how much? 2 sin x cos x. Okay. So next step, this dy by dx becomes dz by dx, which is 2 sin x cos x multiplied with cos x. Okay. Plus z. Now what was z? Z was sin square x multiplied with differentiation of sin cos x, which is minus sin x. Okay. plus cos x. So finally we got it. So it's just, repeated application of the same thing. On its own, you can see any step is not difficult. It's just that we have to do all the steps one after the other multiple times.
Sir,
Yes.
so how did you get dz by dx equals to 2u into cos x?
ये ना dz by du. So z क्या है, u square है ना. So
Yes.
u square का differentiation क्या है, 2u है.
Okay, into okay. Sir.
Understood ना?
Yes,
And similarly u क्या है, sin x है. So du by dx कितना हो गया, cos x हो गया.
cos x. Okay.
So basically for these steps we are using these substitutions only ना. These two substitutions we are using here, right?
Yes, sir.
Okay, so if you come across a lengthy question like this, you have to just be patient and using the different steps one by one. Okay. Okay, people. So I hope the steps are clear in this question now. Finally,
Yes, sir.
right? Okay, let's come to the third one. With this question, so we'll discuss about this. So this is again not such a difficult question, just that you have to patiently use chain rule. So in this, what you can do is you can just treat y like 1 by z, where z is equal to this function x plus root x, and directly apply chain rule. In this, you don't have to use multiple properties. It's just once you have to use the chain rule.
Sir,
Yes.
sir, in this case, we could also rationalize the denominator, no?
But a little bit louder, please. I could not hear you, Harsh.
Sir, now can you hear me?
Yeah.
Sir, so in this case, we could rationalize the denominator, no?
You need not rationalize. I mean, see, it's not necessary always to rationalize the denominator. You can leave the answer this way only. Okay.
No, sir, not in the answer, but in the question. So directly we could get x minus root x upon x square minus x.
But then how that would help us better? Then you'd have to use quotient rule or something, no?
Yes, sir. So that
So-
would be better than chain rule or anything, no?
I don't think so, because see, quotient rule तो हम directly भी use कर सकते हैं ना. We can even treat this like this, that y is equal to some numerator divided by denominator, where the numerator is equal to 1, is a constant, and the denominator is equal to x plus root x. So you can also use this method without rationalizing only. You can write dy by dx as denominator into differential of numerator minus numerator into differential of denominator divided by denominator square. Now you can see that numerator's differential will be 0 because it's a constant, and denominator's differentiation, just differentiate this term. So x's differentiation is 1 and root x का differentiation क्या है? 1 by 2
1 by 2
root x.
root x.
अब इसको यहाँ पे directly substitute कर दो तो ये 0 minus 1
plus
into
1 plus 1 plus.
1 into 1 plus 1 by 2 root x ऐसा आ जाएगा, divided by this denominator which is x plus root x squared. So you can do this way also. So it's directly minus of 1 plus 1 by 2 root x divided by x plus root x whole square. In fact, the first time I did the question also over there above, I did it this way only. So now I
Now,
can
sir,
just
we
take
can.
LCM.
Yeah, sir.
So it is 1 plus 2 root x divided by 2 root x into x plus root x का whole square.
You
Correct?
can take out the x. Okay, and for the-
Yeah, we can do that also. So this method is clear.
Yes, sir.
Yes.
Yes,
But
sir.
I think even easier than this is the chain rule method. See, you can just write y as 1 by z, where z is equal to x plus root x. No? So now we can see that dy by dx is dy by dz into dz by dx. Okay. Now y क्या 1 by z, so dy by dz क्या हो जाएगा? Minus 1 by z square, and z is this, so dz by dx is how much? It's 1 plus 1 by 2 root x. Okay. So substitute this here and substitute this here. So you get this step, you get this step again, and then just resubstitute. So this is minus 1 plus divided by z, which is x plus root x whole square. That's it. It's the same thing. So, I mean, doesn't always really matter which method you are using. In certain questions, one method will have a distinct advantage over the other. But here, I think both this and this are equally easy.
Yes, sir.
Okay, so hope this is clear, people.
Yes, sir.
Okay, very good.
So,
Yes.
so can you just once again write the shortcut for chain rule
Which
formula, sir?
one?
Shortcut for chain rule.
हाँ, by chain rule. हाँ, shortcut ऐसा होगा देखो. This that we have written, y is 1 upon, what was it, x plus root x. So this is f of gx, where what is gx? Gx is x plus root x, and what is f? F is 1 upon g. Okay. Now you know that what is differentiation of 1 by x? It is minus 1 by x square. Okay, so just make use of that. So dy by dx, f prime of gx into g prime x. Okay. Now f is the 1 upon g function. So its derivative is minus 1 upon g squared. This thing.
Yes, sir.
And g is this thing. This. So we need to differentiate this. Plus root x. So this is minus 1 upon, now g is x plus root x whole square, and into 1 plus 1 by 2. Okay. So and then you simplify this. So this is without doing the substitution, by directly using the formula of chain rule. So this is also chain rule formula directly used. Okay, so all the methods are clear, everyone?
Yes, sir.
Okay, very good. Okay. All right, now we will, so now that we have done some practice with all this, we will see an example or two of application of chain rule in physics problems. Okay, so applications of, in general application of differentiation. So first type of application, differentiation is a what we call a rate measurer. It measures the rate of something. Okay. So for example, if displacement is a function of time for a motion, let's say along a straight line. So where s is displacement and t is time, let's say in meters, and time is in seconds, then instantaneous velocity is simply defined as instantaneous rate of change. This equals the instantaneous rate of change of displacement with respect to time. So this is a direct application of differentiation as a rate measure. It is giving you the rate of change. Okay, so here v will become differentiation of whatever this function was. We'll operate using all the knowledge we have of differentiation, and we'll get v is f prime t, and this v that we'll get will be in meters per second, because s was in meters and t was in seconds. So for example, even if we have something more complicated than we are used to, like suppose we have s is equal to 20 sine pi by 6 t, okay, where s is displacement along a straight line in meters and t is time in seconds. Okay. Now we want to find instantaneous velocity as a function of time. And we want to find average velocity from t equal to 0 to 2 seconds, or let's say t equal to 0 to, let's say, 3 seconds. And then we want to find instantaneous velocity at a particular instant of time. We want to find v at t equal to, let's say, 2 seconds. So let's see. So we will use this concept over here. Okay, we'll directly use this concept that instantaneous velocity is rate of change of displacement with respect to time, and average velocity is average rate of change of displacement. So we can write it as S2 minus S1 upon T2 minus T1. So just the treatment we have done to functions, the same treatment we'll do here. Okay. For a given function y is equal to fx, the average rate of change delta y by delta x, we had written as f of x2 minus f of x1 divided by x2 minus x1. Okay. And the instantaneous rate of change was nothing but differentiation applied to that function. So that concept now we will be applying, but instead of y and x, the variables we are using is s and t. Now t is the independent variable of time, and s is the dependent variable of displacement. That is, displacement is varying with time according to this. Okay? And obviously in this 20 is a constant and this pi by 6 is a constant. So just make a quick note of this concept, that one of the major applications of differentiation in physics is that, you know, differentiation is directly used as a rate measurement. Okay, so you can even think of this like a direct application of differentiation. That's a direct application. That when we define some quantity as the rate of change of the other quantity, so we can use differentiation directly to measure that rate of change. And then, having understood this and written this down, now next thing you can start applying that to this particular function. So here s is displacement, t is time. So displacement is given as a function of time. Okay, so just try out this question after noting this down. I'll explain the So people waiting for your answers. So basically we'll just use this concept. S is some kind of function of time, and that function is given to us like this. 2 sine pi by 6 t. Okay. So you just want to understand the form of that function. You can just compare it to something like this. Y is equal to, okay, you can say some a sine kx type of function, where a is a constant and k is also a constant, which is pi by 6. So in this function, if I asked you how to find dy by dx, so what you do is you'd apply chain rule. You'd substitute kx as z, so y would become a sine z. Then you'd apply chain rule. Then you'd solve it. So like that, you have to just apply that concept over here. So instantaneous velocity is going to be differentiation of this. Okay. So when I come down to the differentiation of this, you'll see we get 10 pi by 3 cos pi by 6 t as our value. So this will be our instantaneous velocity as a function of time. So I've not done all the steps, but you can see I've given you the hint about how to use the steps here. So that's the first part. Okay. Then second part is nothing to do with differentiation. Second part is average velocity. So average velocity is delta S by delta T. So it is S2 minus S1 upon T2 minus T1. Now we are calculating the average velocity for which interval? 0 to 3 seconds. So we should take T1 as 0. So we'll take S1 as 20 into sine 0, which will be 0. And we'll take T2 as 3 seconds. So we'll take S2 as 20 sine pi by 2 ho jayega, which is 1. So it's 20. Okay. So now just substitute that here. So T1 S1, T2 S2. Substitute them here and you'll get the average velocity in meters per second.
So
Yes.
So how did you got your 10 pi by 3? Like by
Why
chain?
did we get, sorry, 10 pi by 3? Huh? Because
Yeah.
देखो ना, यहाँ पे जब when you use chain rule ना, there will be a constant term k, and what is that constant? It's pi by 6. So it's actually 20 into pi by 6. Okay, that's why I told you that you have to be a little careful when you are using the chain rule for differentiation, right?
Oh, okay.
Okay, it's like, you know, like just for a moment, let's understand another example. Suppose we have y is equal to sine 2x. Okay. What is the differentiation of this? This is not cos 2x. dy by dx will not be cos 2x. It will be 2 cos 2x. Okay. Because after all, this is also a composite function. No? What is happening here is that y is equal to sine of something z. Let's say where that z is equal to 2x. So dy by dx is dy by dz into dz by dx. So dy by dz will be cos z. Okay. But dz by dx will be 2x. Will be 2. No? So it becomes 2 cos z or 2 cos 2x. So like that, if you apply these steps over here, you'll see that dy by dx will come out to be k into a cos kx.
Okay.
So now if you just compare this function with this one, this is your k and this is your a. So it should be k into a cos k kt. So that's how you'll get this factor of 10 pi by 3. Is it clear now?
Yes, sir.
Okay. So I have just skipped all these steps and given the answer directly, but I've given you the hint on the side here. So just apply those steps of the hint. You'll understand easily how you get this.
So substituting t here in the after we differentiate the entire equation, we get the value of s, right? Not v. We then have to divide it by t to get.
Sorry, I didn't get you better. Thoda sa और loudly बोलो.
So when we differentiated this equation, so what we got 10 pi by 3 into cos pi by 6t. So if we substitute the value of t by any constant, we will get the value of s, right? Not t.
You'll get the value of instantaneous displacement at that time. Like for example, here I've substituted t2 as 3 seconds now. So I'm getting 20 sine pi by 2, which is 20 meters. That is not the velocity. That is the displacement at that time. Whereas if I want the velocity at that time, then I should substitute t in this equation, v wala equation, as that time. Got it now?
Yes, sir.
So for the third part, we have to do that. For the third part, we have to substitute t in which equation? in this equation, the instantaneous velocity. But if I substitute time in this equation, the S equation, it will give me the displacement at that time and not the velocity.
Yes.
So,
Yes.
so here where you wrote S2 minus S1 divided by T2 minus T1, it will be then 20 minus 0 divided by 3 minus 0, right?
Yes, so very good. So it will be 20 by 3 or approximately 6 by 67, 6.67.
Yeah.
So our average velocity here will become 20 meters divided by 3 seconds. So our average velocity will be approximately 6.67 meters per second, but this is for that particular interval for 0 to 3 seconds. If I take some other interval, it will become a different value.
Yes.
So as I said, the second part was nothing to do with differentiation. It was to do with the concept we had earlier learned, average rate of change of function, delta y by delta x, y2 minus y1 upon x2 minus x1. Whereas the first term was we are finding the instantaneous rate of change as a function of time. And then again, the third one switches back to rate of change only, but we have to find the value of rate of change. That is the value of velocity at the instant t equal to 2 seconds. So I got here velocity as a function of time already from differentiation. Now I have to substitute the value of time as 2 seconds and just get the value of velocity. And of course here the V that I'm getting will be in meters per second because I'm substituting time in seconds and S was in meters. Okay, so finally the third part's answer. I want the instantaneous velocity at the moment t equal to 2 seconds. So I should take this equation 10 pi by 3 cos pi by 6 into t, but I should substitute the value of t as how much? As 2 seconds. Okay. So it will become 10 pi by 3 cos pi by 3. Now cos pi by 3 you know is half.
So half.
Same thing as cos 60. So 1 by 2. So this will become 5 pi by 3 meters per second, or we can 3.14 divided by 3. It will become very close to 5.2-ish meters per second. So this is the instantaneous velocity at 2 seconds, whereas this is the average velocity between 0 to 3 seconds. The method is clear now to all of you?
Yes, sir.
Okay, so now obviously kinematics and motion is the obvious situation where we use rate of change concept, but there are many other situations also where we use rate of change. So let's look at another example of that. So suppose we have this situation where we have a metallic sphere, solid metallic sphere, so like a solid ball of metal. Now we are gradually heating this. So as you know, all metals expand on heating. So we have to do something about the rate of change of the size of the ball. So it's something like that. So this is a solid metallic sphere. So it's being heated slowly. Such that its radius r is increasing with time t. So now suppose if at a certain instant of time r is increasing at the rate of, let's say, 0.2 millimeters per second, and the radius itself is equal to 10 centimeters at this instant. Then we want to find the rate of change of its volume V, and we want to find the rate of change of its surface area S. Okay. So how we'll approach this question is now like this, that we will use differentiation
Sir,
as a rate measurer only. So what you'll understand is that R is changing with time. Okay. So that means dr by dt, this is the rate of change of R with respect to time. Okay. Now further, volume V is given by this formula, as you know, for the sphere. So volume is a function of the radius. So to find the rate of change of volume, we'll have to use chain rule. And like that for surface area also. So not only we have to use differentiation as a rate measure concept, but we have to also apply chain rule when we are trying to find the rate at which V is changing, given that we know the rate at which R is changing. Okay, so just try this out by the method I just told you. So just read the question and interpret the meaning of this, that radius is increasing at this rate. So what it means in terms of rate of change. And I've given you the formula, or you already know the formula, how volume is related to radius. So how we will relate the two changes, rate of change of volume with the rate of change of radius. We'll relate it by using chain rule. Volume depends on radius and radius is changing with time.
sir,
Okay, so let's first interpret what this means, that at a certain instant of time, R is increasing at the rate of 2 millimeters per second. So what this statement means, that dr by dt is equal to 2 millimeters per second is the rate at which the radius is increasing. Okay, and at that moment the value of radius is 10 centimeters, or we can write that as 100. This is the instantaneous value of radius, and this is the instantaneous rate of change.
0.2 millimeters. It's 0.2.
Okay, so now what we can say about the volume?
Sir, it's 0.2 millimeter.
Sorry,
It's 0.2 millimeter. The rate of change of R.
so we'll find a value, no? It won't be a function of time like that, no?
What's the
It will be
value
the-
over there?
it will be a value. Okay, so let's see how we'll find the value. Okay, so now see, we know that volume as a function of radius is 4 by 3. It's 4 by 3 pi r cube. Now we want to find dv by dt. This is what we want to find, the rate of change of volume. We want to find this out. So to find this out, we'll have to use chain rule. This is dv by dr into dr by dt. So this is the chain rule application. Because volume depends on radius, and radius is changing with time. Okay. So this is going to be differentiation of this expression 4 by 3 pi r cube into dr by dt. So 4 by 3 pi is a constant. Differentiation of r cube is 3r square into dr by dt. So we get an expression that rate of change of volume is 4 pi r square into dr by. Now we can substitute the given values. So in general, at any instant when the radius is r and the rate of change of radius with time is dr by dt, so at that given instant, so at this particular instant, the rate of change of volume is 4 pi into, we can write this as 10 centimeters square into this as 2 millimeters per second. We have to convert one of these two.
Sir, it would be
0.02.
0.02, no?
So we can change this as 0.02 in centimeters per second.
But
So
sir,
that-
it is 0.2 mm, no?
Yes, in the
Oh, it was
question.
0.2. My mistake. Okay, sorry. It was 0.2. So this will become 0.02. It's 0.2 in millimeters per second itself. So in centimeters per second, it will become 0.02. So as you can see, this will become 8 pi centimeter cube per second. That should be the unit of rate of change of volume, no? Because volume is in cubic centimeters. So the volume is expanding at the rate of 8 pi or 8 into 3.14 cubic centimeters per second. This is the rate of change of volume. With respect to time, that's this.
So,
Yes.
so when you wrote 4 by 3 pi r cube, and then
Sorry?
so where you wrote 4 by
Ah.
3 pi r cube,
Ah.
then you did the differentiation of r cube, which is 3r square, right?
Correct.
And so, like 4 by 3 pi differentiation, like.
No, it's just a constant, na, beta. So it's coming outside.
Oh, okay.
You understand? Na? The term 4 by 3 pi. Pi is also just a numerical constant, and 4 and 3 are just two numbers, right?
Yeah.
Okay, so we are just using that property.
So can you scroll up?
Yeah, I'll scroll up. Okay. Now see, you think of the same thing how we can use for the surface area. Okay, just like I've done for the volume, you have to do for the surface area also. So you know that there's another formula for surface area. Now, what is surface area of sphere? What is the formula for surface area of sphere? Can anybody tell me?
4 pi r square.
Very good, that's correct. Okay. S is equal to 4 pi r square. Okay, so again for ds by dt, I want to find this out. So I'll write ds by dt by chain rule as ds by dr into dr by dt. And then I'll use the same method.
So can you scroll a little bit down?
Yeah. Sorry?
Can you scroll down?
Yeah, sure. So you got the data from the question now.
Yeah. So, so we can also put the value of r, which we got as 100 mm, into the formula 4 pi r square, like the differentiation. So that
See, one thing you have to understand, if you directly put the value of r as 10 centimeters and differentiate, you're calculating s at a particular time, so it's no longer a variable. So your differentiation will give you 0. You understanding my point now?
yes, sir.
So that's why now whenever we differentiate a function, so it's like, if I say that we have a function y is equal to x square, now calculate dy by dx for x equal to 5, let's say. Okay. So what you'll do is you'll first differentiate this. That's 2x. And then you will calculate dy by dx's value at x equal to 5, and that will become 10. You should not do these steps in reverse. If you first substitute x as 5, then you're getting y as 10. But that's not a function anymore. No? It's the value of y for a particular value of x or 25 or whatever. No? It's not. So differentiating this will not help, no? Because you're getting the value of the y at a particular value of x. So it's no longer a function. You're understanding the point, no?
Yes, sir.
So same thing over here. So you have to start with s as a function of r. So what is happening? S is a function of r. So ds by dt is the rate of change of that function with respect to time. And then I'm using the chain rule formula. So it becomes differentiation with respect to r of that function into dr by dt. So it's the derivative of that function into dr by dt. Now that function in this case is what? That function is 4 pi r square. So the derivative of that function will be 8 pi r. So that's how we'll get the second part. Okay. So S is equal to 4 pi r square. So ds by dt is equal to ds by dr into dr by dt. So that is so again 4 pi is a constant and differentiation of r square is 2r. So we get the formula of the rate at which the surface area is
0.5.
Yes, it is 8 pi r dr by dt. Okay, so this is a general formula. Now we will calculate this rate at the instant when r was 10 centimeters and the rate of change of r was 0.2 millimeters per second. So this will become 8 pi into 10 centimeters into 0.2 millimeters per second. So this will become in centimeters square per second, it will become this much. This will be the instantaneous rate of change of surface area. Or is it 1.65?
Yes, sir, it's 1.6.
1.65. Yeah, hope this is clear, people.
Yes, sir.
Yes, sir.
Right, 1.65. Okay. So people, with that we conclude today's session. Now, like there might be some questions and all pending for you from worksheet 3. Don't worry. Next lecture we will discuss any doubts if necessary. Even though I sent you the solutions, but still, if you have any doubts, and there will be another worksheet coming up with these kind of applications. And next lecture we will see more applications of differentiation in something called calculation of maximum and minimum value of a function. So you can look that up in your module also ahead. Okay, so that's it for today's session, people. Thanks for attending and wish you all the best. Have a nice day.
Thank you,
Thank
sir.
you.
Bye, sir.
Thank you,
Yes,
sir.
sir. Bye,
Bye.
sir.
Bye, sir.
Okay, bye.
Thank you, sir. Bye, sir.
Enjoy the monsoon.
धूप चली गई मेरी। तुम हेडफोन क्यों गले में